Hello everyone, if you haven't subscribed, please click the subscribe button so you can get updates. Okay, I would like you to read the problem silently or you can pause and read. Let's answer question number A1. Let plot the position of Z on organ diagram. This is our Z. So say 1 is our real part and negative 1 is our imaginary part. So your Z is here. That's your Z, which is equal to 1 minus I. Okay, for let number part 2 of A, express Z in this form. This is Euler's form. And your answer A and B must be exact. So A is the magnitude. So you get the magnitude of A using your calculator. That's equal to square root of 2. And our argument is equal to negative pi over 4. You can use your calculator for this. So Z is equal to square root of 2 e raised to negative pi over 4 I or negative I pi over 4. Okay, so we're done with these two. For letter B, part 1, find the sum in this form. So W sub 1 plus W sub 2 is equal to e raised to ix plus e raised to ix and I multiplied by x minus pi over 2. So what we can do here, because we need to write it in this format, we can factor out e sub ix. So dividing this by e sub ix give you only 1, and dividing the whole thing by e sub ix gives you e to the negative pi over 2I. Okay, but this is not in Cartesian form. We need to write it in Cartesian. So you can, again, get your calculator and change this to rectangular form. In your calculator, you press menu, number, complex number tools, and then convert to rectangular. So e raised to ix, this is equal to 1 minus I. Okay, this is the final answer for B1. B2, hence means that we need to use whatever we have uh, on top. So means say you can use the answers, the previous answers. Find the real part of this in the form a cosine. It's the real part is really the cosine. So we get the real part of e raised to ix 1 minus I. Okay, this is the same as the real part of e raised to ix, and 1 minus I is square root of 2 e to the negative pi over 4 I. Let's take a look at that. Where is it? This one. Okay, so we need to write it in cis form or cosine I sine. So this is equal to square root of 2 cosine our phase shift is -4. So it's equal to x minus pi over 4. Okay, so we're done with this. We have seen the same format. Okay, we now find the maximum value of I sub t or subtotal, which is, I think it's here. Here, it's I subtotal could be expressed as this one. So let me just move a little. Okay, letter C. We have I total is I sub A plus I sub B, which is equal to, this is actually this one. The phase shift is 0. So 12. What's the format? This is the format. So we have 12 cosine bt plus 0 is simply cosine bt plus I sub b, this one, is 12 cosine, the format is bt, this is the format, plus bt minus pi over 2. Now, we can get their common factor, get the 12. Since we're dealing with cosine, we're dealing with the real part. So real part of, let's just change this to Euler's form. So e raised to bti plus, because we already removed 12 there, we have e raised to this one, bt minus pi over 2i. Okay, so 12 times the real part of, let's get here, let's just move this up so we can have enough space. So we shall get the common factor e, b, t, I. So it's equal to 1. What's left on the other side is e to the negative pi over 2i. And I think we already know the answer here. It's equal to 12 times its real part. This is 1 minus a. This is equal to real part of square root of 2 e to the negative pi over 4 I. Or we have here, if we're going to write this in cis form, 12 square root of 2 cosine bt minus pi over 4. So the magnitude is 12 square root of 2. Since it's not mentioned whether our answer is exact or not, another answer, which is intrinsic fig, is also accepted, 17.0. 0 there is significant. Okay, and for part 2, our phase shift is pi over 4, or if you use decimal, you can have 0.785. You need only to show one answer. So if it's exact, it's square root of 2 for the magnitude, and for the phase shift, it's pi over 4. Stand by for the answers in problem number 4.